All right. Good afternoon, everyone. I see we have four early starters, two of whom I recognize immediately. Derek, is it still Derek, or should I be saying Dr. Hacknell?
Still Derek for now, and it's always Derek for you anyway.
Fair enough, sir. And I see Nicholas Mendez. Nicholas, I made you co-host. Nicholas, from the time I mentioned doing this course, he said, listen, because he's a lecturer on campus. I want to be a TA. I don't know what you're doing, but I want to be a TA. So he jumped in. So making you co-host to help me with people who may come on a little later on, just to accept them into the room as they come along. And beyond, I see Nicholas Smith and Kellem. Since I want to give people a few more minutes, maybe we could just go around the room and introduce ourselves and attack some of this virtualness with some reality. So Derek, maybe we could start with you. Our things, how are you going?
I guess well. Things are hectic for now.
Yeah.
But doing well. So my background is in education. I've done some software development stuff, but it's been many years, and right now I'm into project management.
Okay. Okay.
Yeah.
Nicholas, you want to take it away?
Are you referring to me or Mendez?
Apologies. Mendez first and then you, Smith.
Okay, no problem.
All right, very good, everyone. An instructor at the Department of Computing and IT, and I work closely with the software engineering courses, so naturally I had an interest in what was happening here. Happy to give any support I can.
Nice. Then you, Nicholas Smith.
Sure, no problem. My name is Nicholas Smith. I'm currently doing my last semester in computer science at UE. I've also done some contracts under Nicholas Mendez for DCIT for the internship and outside of that. And also I am working with another doctor on a research project. And also right now I'm trying to improve my software engineering skills, trying to get better at that and go into the field of machine learning. So I'm taking online courses to understand machine learning better.
Okay. I don't know when and I don't know how frequently I will tell this story, but that sounds very much like my undergrad experience. I worked with a medical doctor for a few years while in undergrad. Please don't laugh at me, right? We're here to tell the truth and to learn together, right? But I worked with this doctor to create databases for him. You mentioned machine learning, and that's super fancy. I made access databases for him and queries on those access databases. I mean, I was a student assistant and I paid, so that was cool, but it also kind of gave me my first interactions with delivering something that somebody needs, because he came to me saying, can you build access databases for me? And I said, sure, even though I hadn't ever done that. So it was a fun time. You reminded me about that, and I'm happy to hear that culture of start while you're there, look for relationships and look for opportunities while there is still fresh. Nicholas Smith. Kalem, you want to go next? We're just introducing ourselves while we wait for a few more people to join us, guys. I hope you don't mind.
Yeah, sure. My name is Caleb Mentor. I actually went the self-taught routes. Currently I work for a company in St. Lucia. And yeah, looking forward to the course.
Nice. Kalem, what company is that, if you can share?
Optronics is the name of the company.
Oh, you are the guys with the procurement solution, right?
Yes, that's me actually. Most of it is me actually.
Okay, wonderful, wonderful. What about you, Cameron? I will stop the introductions in a little while if it gets too much, but I like it, so we'll keep going for a little while. Cameron, go ahead, if you can.
Oh, hi, sir. Good evening. Cameron just finished work like literally 5 minutes ago, so he just stepped away to get something to eat.
Sure, okay.
Yes,
I like
just
it
wanna
when you're ready. This is a very short course. There are no group projects, but you're tempting me even now, Sadia. Well, since you have the mic, you want to go ahead and say who you are, where you're from, what you're doing?
Yeah, sure, no problem. Hi everyone, I'm Sadia. I have my bachelor's in computer science with management, and I'm currently working for a software company. and I'm from Trinidad.
Sadia, what company?
Oh, it's a Canadian company, Peer Ledger.
Okay, all right. But you say peer ledger. Is that like a blockchain thing? Is it super fancy?
Yes,
Oh, nice.
blockchain. Yeah.
All right, cool. You mentioned computer science with management. They still offer
Yeah.
that degree, is what you're saying, to be clear.
Yes, they do.
Nice. I have the same degrees to be saying good company.
Oh, nice.
All right. Ryan Shripat, TTCS. How you doing? You all right?
Hi, sir. I'm
Good,
a
good to see
I'm a
you.
program
Good to see you.
I'm a programmer at Davin Limited, where I get to write software on a daily basis.
Do you still get to write software every single day, or are your duties a little mixed up now, Ryan?
I try as much as possible to divide my day between criticizing other people's code and writing my own.
I mean, and that's a dream, isn't it? Perfect. I think Kwesi, you're the last one for us for the minute, unless Cameron is back.
Okay,
No, not just yet.
All right, cool.
okay. Well, hi, good afternoon, everyone. So yes, I have my bachelor's degree in computing.
Nice.
Now the thing about it is I'm very passionate about IT. However, I haven't had the opportunity yet to work in the field, right? So I'm just doing some online courses, right? And I'm hoping one day to get the opportunity to get into the field of IT, right? So like I said, I'm just happy to be here and really looking forward to taking the course, right?
Nice. So I actually want to start with that remark, Kwesi. This kind of feels like we are at Maracas. I'm going to tell a story that Nicholas Mendez knows really well. We both participated in a... Nicholas, let me ask, are you doing it this year? I see it's happening in May.
Yeah, it's happening this Sunday, so
Are
I'm
you-
going again.
Amazing. Nicholas and I participated a couple of years ago in the Maracas open water swimming race. I did it at the lowest level, which is 1K in the water. I thought about that, Kwesi, because prior to that, for many years, like I imagine you would have been going to Maracas and then go to the beach, you dip your toes in the water, have a good time. Maybe even you walk out into the little deeper parts, you jump up and down and feel like a swimmer. Like that's how I used to feel. And so to some degree, enjoying the beach is free. Enjoying the space, doing it for whatever you want, carrying a dog for a walk or just hanging out, eating some bacon shark. The nice thing is there's an opportunity at Maracas to level up. You know what I mean? To go from a casual wave surfer to something more. And I mean, the experience of doing it, it might be a one-time thing in life for me, Nicholas, to be clear. But the experience of preparing for that, which took me on a real massive journey. I've been running for many years, which is why I have this very cool running jersey. Been running for many years, but swimming was a different beast. So I trained for like a year and a half to even do that 1K in the water, and it was pretty horrible, to be clear. I think I probably came third to last or fourth to last, somewhere near the bottom. It took 45 minutes to swim 1K in the water, but it was amazing. It top tier activity for me. And so the idea of getting your feet wet, even using an interaction like this, coming to this one day is perfectly fine. And if you decide to, like me, venture out into deeper waters, hopefully like me, you will have a strong support community that could help you truly process and provide some guidance. I want to get started. I have a nice little quorum here, to be honest. I like the numbers. We may do some introductions a little later on if we want to take a little break. I told everyone who's coming that this is a 3-hour class today. It doesn't have to be 3 hours. We may be a little less. If we want to make it a little longer, hopefully not. But I certainly am happy to see you guys here walking through foundations of software architecture. I expect this to be interactive. I expect you to raise your hand if something doesn't make sense. At some point, I'm going to ask you some questions. But even more than that, we're gonna interact together. So I hope you have access to a computer screen so you can at least start with the interactivity on a good footing. So welcome to this developer's path. As you may have heard me say on LinkedIn or somewhere else, The PATH is an acronym. It stands for Patterns and Architecture to Help, or Patterns and Algorithms to Help. It comes from just a realization I've had that learning about design patterns helped me appreciate our world in a very, very different way in terms of writing software. Same thing applies to software architecture, and I hope you have a similar experience to me. So let's get started. Where is my presenter view? Here it is. So first thoughts. To be honest, if you're coming into software development and you've spent a year or two, which is who I expect would have joined this, but people like Ryan or Derek or Mendez would have been doing this for much longer, you know this already, that there are people who don't really care about software architecture because whatever systems they've built have been okay, right? They've built maybe a website here and there, a WordPress business here or there. They've offered small businesses some sort of optimization. You wrote a script to help process sales. Fine. That's actually how I got started. The very first time I wrote code for money, it was to take some XML documents and convert it to other kinds of XML documents. For those of you who don't know, XML is a format, because most of you maybe JSON people. This may be a JSON generation, but before there was JSON, there was XML. Well, it stands for Extensible Markup Language. Anyway, the point is, we took this document format in XML and converted it to another format. I had learned Java for what was 1 semester, and I was able to apply it for this very specific project. Typically, there are other line of business applications. That's what LOB stands for there. The LOB building would not last beyond the next quarter. Many of us would have found ourselves writing line of business applications that have a very specific purpose. It is to deliver this goal for this part of the business in this time frame. And success or failure means meeting the time frame. So the code oftentimes is nasty looking, but it works. And in fact, as I said in line 4, your systems don't work that well, but it delivered the value they needed. And of course, if you are in a place where nobody cares about making things great, they just care that it works to some degree, then maybe software architecture doesn't matter. And so that's one of the things I want us to understand, what I'm kind of offering us in the context of this course, that we are looking to be better in terms of how we build systems and solutions, even though we may operate in a context where it mightn't be demanded right now of you. I hope that makes sense. So let's dive in from what we're trying to do today and understand what a software architect is. And it's funny, I was in a team where we had architect enroll a name, but we actually struggled from time to time. What we used to do, because you're just writing more code, you're just writing code, you're still writing the code writing before. And so sometimes companies do need to make space for the manifestation of architecture as a role, if even someone doesn't have the name or the designation. That's okay. The titles don't matter that much. That's not to say titles don't matter, full stop. From a career perspective, you may want to change your title, grow into different titles. That's perfectly fine. But in the context of software architecture, think of the architect as the role much more than someone who's named such in your company. Beyond that, let's explore some of core concepts in architecture, which may be familiar to some of us if you did anything to do with design patterns before, but it goes beyond design patterns. There's a way of thinking that I would have seen in some of the books that I will speak to or draw from for this course. And let me emphasize, the course we're doing, it's not, I didn't make up the material and I just decided to tell the nation, hey, I'm an architect whiz and let me talk to you about software architecture. That's not how this went. It went completely opposite, really. There are a number of books that I have drawn upon to develop the material for this course, and I'll share them in a matter of time. But it's critical to understand that those books describe something called architectural thinking, and I certainly certainly want us to hear what that is and be able to use it. And of course, from there, terminology. It's not so that you could learn the words and learn it by rote. I saw one guy, his name is Gurgly Oratz. He has a very popular blog website, Pragmatic Programmer, I think is what it's called. And he had a blog post. He was saying, listen, architecture does not matter that much. And I was going to fight him. And then he explained. And when he explained it, what he meant was people remembering terminology and people essentially being able to regurgitate what they have seen is not important in our world. Being really good at memorizing concepts and being able to speak to them quickly without applying them is not that beneficial. Instead, if you can read the books, you can attend courses like this, if you can have the conversations and then use it to address needs, that's what we're going after. Does that make sense? I'm saying it doesn't make sense like I'm in a class because I'm accustomed to talking to faces. I kind of hate virtual classes where I don't see people's faces. If you're not camera ready, it's okay, it's the first day, but it does make for a more challenging environment. Before we go on, I would like us to jump into this form. I told you that the interactivity, we're starting early. Just a list of these, this is not an exam, but it's questions to help us understand where you're coming from. So let's take a beat. I will drop the link in the Zoom chat right now so that I could kind of get a sense of who we are, what we're going after. If I could just get Zoom to open up, please, Zoom. And yeah, Zoom, you could ignore me, Zoom. You don't need to take me on. There we go. Yeah, there it is. Dropping in chat this link. So let me kind of go through the questions. Really simple. We have emailed twice. That's how simple it is. Nevertheless, what did you study? If you studied in school, what you're studying right now? Basic things like this. The important questions for us. It looks long. Answer quickly. Don't think too long about it. But we do want to hear from you what you're looking to achieve in this course, how you see it helping you or your friends or your company, where you've come from, how you plan to apply this knowledge, that kind of thing. Really straightforward. It should take you 2 minutes. So let me give you 2 minutes to kind of go through these questions and we'll continue again. The clock starts now. Go ahead, take your time, and we're gonna continue after that. In the meantime, I see Jerome, Daniel, Bjorn. Is Cameron back?
No, almost.
All right, that's okay.
I sent him the link though.
Okay, good. Jerome, how you going?
Cool. Y'all hear me okay?
Yes, hearing you fine. I don't know if you have the space, just introduce yourself to the rest of us, what you do, what company you're from, that kind of a thing.
Okay. Yeah, my name's Jerome. I am a software developer at Darwin. So seeing a couple other Darwin persons on the call as well. Yeah, so just currently focusing mostly on front-end frameworks, but also working as well on some back-end work with .NET, C#, and yeah.
Okay, nice.
Don't know if I answer all the questions, but yeah, that's me.
That's fine. Daniel, how about you? But Daniel, I'm not sure if your mic is okay, but let's probably move on to Bjorn just to get a sense of who is on the call.
Hi, good day. Bjorn Alonso.
Andre, I forgot the Bjorn bits. Guys, I work with Andre, but
Yeah.
it's a man of many, you know.
I'm still have Bjorn this. So, but I work at IGovTT. I'm a software developer there. I mostly work on front-end frameworks throughout my development career. On the back, I work with PHP as backend language. I've also worked on mobile applications. And yeah, that's about it. It's a big part of this experience. Yeah. Of course.
Very cool. I just saw a message, Daniel. Thanks for the message. Yeah, I think I forgot to introduce me properly. So while you're filling out the form, I could just walk into that a little bit. As you know, my name is Evan Williams. I work with one of my colleagues here, Andre or Beyond, at iGovTT. I'm the head of software development there. I've been lecturing occasionally with UE for probably 10 years now, maybe longer, in various subjects from cloud technologies to distributed systems to now essentially, what do you call it, software architecture. Beyond that, I work in developer advocacy. I shouldn't call it a work. I like developer advocacy. So where there's a hackathon, there's just an initiative celebrating or encouraging developers, I tend to find myself there. Just this weekend, so I work at iGovTT, and iGovTT's parent ministry is the Ministry of Digital Transformation. So just this weekend, the ministry celebrated those participants in an initiative called D-Hub, that some of you may not have heard of, but D-Hub is a wonderful initiative to encourage software developers, budding software developers, experienced developers to participate in the digital transformation happening in Trinidad and Tobago. So we celebrated all the participants of what is called the first challenge series. It actually continues. Those developers will be expected to build out MVPs for the projects that were so selected. So it's a little bit of who I am, building developers, building cool applications, and having fun in between is how I spend my time. All right, that feels like 2 minutes, maybe longer. And take a quick check to see if anybody filled out this form at all. It'd be good if you did. It'd be good. Let me see. I followed custom. There you go. I got responses. Thank you, guys. I'm not going to evaluate them now, but feel free, everyone else, to fill it out as we go along. Right, and I will share the link at the end as well for you to, if you didn't get a chance to take another chance at it. So let's start off. There's a few ways I'm going to be doing this course, guys. One, there'll be a lot of talking. Of course, it's you have to find some way to communicate with each other. So I'll talk a lot, but beyond just talking, I expect that you will share a lot with me, either by talking or by chatting or by assignments or whatever, like this one is. This is a kind of an unfair assignment because I'm asking you to analyze an application, to discover and determine its architecture style and articulate that style and how its design addresses requirements like scalability, performance, and maintainability. That's kind of unfair, to be honest, to ask you to do. If you're not familiar with that, you have no applications to work with, or you just wouldn't know what to say, right? So be true to that. Well, the other thing is, I have a link there. I'm hoping this works. It may not work, and I'll tell you why for a very basic reason. I use ChatGPT a lot. So I built a custom GPT for this course. ChatGPT is the service from OpenAI, and they allow you to build custom GPTs that really are verticalizations in my mind of the ChatGPT service and experience. It's not particularly fancy. For me, it feels like just templated prompt engineering. It's not that hard to do. But when you do it and you have some time to play with it, like I have had for the last 3 to 6 months in building out this course, you get some useful results. So if you look at this assignment, sometimes you might want some help to do that. So I took this custom GPT I built, and I call it this developer Spark agent. Now, mind you, you could use this now if you wanted to, but you need to have a ChatGPT Plus account. You don't need to do that for this course. I'll just keep using it as I need to. The reason why it might not work is very simple. They limit how much you can be talking to using their models. So if I talk to it too much, like I did a few nights ago, they'd be like, take a break, Owen. You know, Netflix asks, are you still watching? It's like a reverse of that. Are you still chatting too much? Take a little break. Nevertheless, I took that same question, analyze an application. I built this agent, and the agent is focused on this course. It's focused on the material of this course. So given this assignment, and one of the books, as I mentioned, I'll talk about the books a little bit later on. Fundamentals of Software Architecture is one of the books we draw from. Analyze the an application to essentially the same question. Analyze an application to identify its style and discuss how its design addresses specific requirements. So I gave you this assignment. Maybe we can't quite do it just yet because we don't have the language, we don't have the experience, we don't know where to begin. Check what the agent is starting to help us. And this is how you would actually begin to answer this question. And as you heard me say, as you saw me say, yeah, use the book Fundamentals of Software Architecture.
Sorry, are you sharing screen?
I was. Are you no longer seeing my screen? Oh, Nicholas, I think because I made you host.
Okay.
So hold on. How my screen has not being shared at all for a long time or what?
I haven't seen the screen at all.
I haven't seen your screen.
I think we saw something, but it came off just after the form.
Well, Nicholas, I think I may have to reclaim the host title simply because it took away my screen share and I need a screen share. So that means I was just talking to the screen. You guys been seeing my face for this whole time? Apologies, all of you. Right. Are you seeing my screen now?
Seeing it now.
Yes, we are.
So all this stuff you weren't seeing.
No, we won't.
Well, here we are. Here we are, guys. Good opportunity to revisit what I just said. We mentioned this before that we don't need to kind of go back over this. I mentioned the learning objectives as well, and we just went through this form. So now we're here at this assignment, which I'm hopefully we're all seeing. Thank you for asking. I don't remember who just asked, but thank you so much for asking. This is the agent I built, and I gave it the same assignment question because I wanted to use the agent to talk about how to answer this question. He bunks up an application in a company. Like my very first, what's my first? No, I work in a very long time, not that long. But one of my first jobs, I was at Clico. I was an application support specialist. And they gave me a VB6 application this is more than 20 years ago, I think. A VB6 application, even though it's 20 years ago, to be clear, VB6 was old then. So they gave me a VB6 application. I would have just come out of school. I may not have even been writing code in .NET yet, just to figure out my timing. I would have been good at Java and good at ASP Classic. There may be only one person on the call who appreciates what that means when I say ASP Classic. But that's what I was versed in at the time. Maybe a little bit of PHP. And they gave me a VB6 application to essentially do this, analyze it, and figure out how to make changes. I think because somebody had written it and they left. So now they needed the new guy to figure it out. This framework, I loved it as a way of answering the question. How to identify the style. Well, first of all, you need to know what styles exist, which I mentioned in the learning objectives. So if we go back here, we want to talk about some of these styles: layered, microservices, event-driven, whether it's monolithic or distributed, things like that. So you want to be able to do that, take a look at application structure. And of course, it's good if you have some working material in your hand, like the book I mentioned, Fundamentals of Software Architecture. Going beyond that, talk about how the application may scale. What is the approach to scalability? We will touch on what this scalability is just one of a number of architecture characteristics that you should be aware of. But if you're analyzing an application, taking a look at it through the lens of architecture characteristics makes a lot of sense. And then performance. How does it work? How does it handle requests? My application, my VB6 application wasn't quite, this is a Windows application at the time. It didn't need to handle that many requests simultaneously. So maybe the thing for me would not have been to measure performance necessarily, but there may have been another kind of characteristic like maintainability. How is the code written? What does the modularity look like? How do you deploy this? What's the use of solid? Which are object-oriented principles, which maybe we should know if we don't, we'll get a chance to talk about still later on. And then what were some of the trade-offs we see in the application? So part of why I'm showing us this is for a few reasons. One is, I don't think any modern course on software should talk about software development and software growth and architectural growth without admitting that we're in a new world today. We're in a place where large language models are forcing themselves into the room and into the discussion. Just maybe by show of hands, anybody here uses a large language model for the day-to-day coding? If you do code during the day-to-day? How do you show hands in Zoom? There you go, Nicholas Smith raised his hand. There you go. Only Nicholas, so the rest of us lying just like that. Straight so. Both Nicholases are honest. And the rest of us just want to hide it. And that's okay. I respect you for hiding it. You don't need to hide it. I kind of expect it. I expect the engineers who I work with on a daily basis to be like, hey, we're going to ChatGPT to design something. Or I'm using Gemini or Claude or any of the models. I've been, as you can see here, I'm using large language models to build out aspects of this course to make it a point of discussion. So that's our first assignment, right? Analyze an application. How would you do it? Remember, this is a 5-week course. We don't really have that much time to give you projects that last for 2 months and they come back. Look what project I finished. You don't have time for that. You need to give you the answers sooner so you can use these tools as you go forward in your day-to-day. I'd love to hear that we've started. If so many of us, because many hands were down when I asked about large language models, if so many of us don't, I'd love to see that number go up in a way that makes sense. Some of us may have seen the Devon announcement about a month ago now. If you hadn't, Devon was advertised as an AI software engineer. Such lies. Maybe it is for them, but software engineering is much more than about the lines of code that are written on who writes it. And we'll touch on that in a little bit. But I expect for architecture, for all the other kinds of things we're doing today, we're using all the tools at our disposal to get the job done. AI and other things included. Right, so let's keep moving forward. So we want to talk about software architectures. We'll define it a little bit and define what we expect of our people who do architecture and what decisions look like. So this is my definition, kind of a combination of what I've read and what I've experienced. It consists of the structure combined with the characteristics. Notice there's a dash ilities there. One of my really good friends and a senior developer himself, he spent time specifically drawing out these attributes. We had a few names for them. One was abilities, the other was attributes that describe the software. Here's one thing you will hopefully never hear me say again after I say it now. You'll almost never hear me say that architecture characteristics are called non-functional attributes. You guys ever heard that term? You probably heard it in school at some point if you did any software engineering. My deep hope is to never refer to it as that. I think that is a horrible name, a poor choice to describe what the thing is. Beyond that, software architecture includes the decisions and the design principles of the software product or service. Non-functional requirements, a horrible title. So when we talk about software architecture, the structure is maybe some of the type of styles you heard me mention a while ago, and we'll touch base on some of them, whether something is monolithic or distributed, whether there are a number of layers, whether it's in fact a big ball of mud. That represents the styles that we used. These are the characteristics, and we'll break it down in a little while. They're not all the characteristics, but they represent a nice snapshot of them from availability all the way across to learnability. Those represent some of the goals of your system. You need to have a certain degree of availability, or you need the system built in such a way that testability is easy. There's a high degree of testability. It doesn't have to be test-driven development, but your system should have all the tests needed to confirm it works fine. It works according to spec or inside of the scope. Along with the others, we'll touch on in a little while. So software architecture is the structure, characteristics, a track record of the decisions made for building the system, and the design principles. Honestly, I love this definition, even though, to be honest, I didn't know prior to, so I've been trying to get this course off the ground for maybe close to a year, maybe longer. And so I'm happy all of you are here. Thank you for joining us on this journey. I didn't use a term that is becoming more popular these days, which is architectural decision records. It feels like it's a step above documentation, and it certainly isn't just a backlog. It's a track record of the choices you made that led you to having the system look like it looks. When you do that, you enable others who come behind to follow up, to question the choices, to see the choices plain as day and why they were made, and then determine if they need to be changed or not. So it's a very big deal to be able to track it deliberately. Over the course of my career, and that's one other thing about this course, I want to use my career as a sort of a lens, perhaps point out some of the mistakes I have made, some of the successes, some of the challenges we've had, and use that to share. So over the course of my career, did we track architectural decisions? Yes. Was it effective? Not always. Sometimes it's an email, it's in chat, it's in a Word document somewhere separate from the application. Eventually, I saw my team starting to use wikis so that everyone could know where to go to find out how this thing was built, but sometimes the wikis weren't populated. There are a number of challenges that could prevent us from living our best lives, and some of them are because of maybe indiscipline, but hopefully it's no longer because of a lack of knowledge. So yes, the decisions used to build the system form part of the software architecture. So let me pause there for a sec. Let me ask you, ask everyone on the call, what has been our experience tracking architectural decisions if we've been so involved? You can either chat or you can unmute and share with us. And mind you, like I said, architectural decisions relate to the characteristics of
Sorry, what's the question again?
What has been our experience tracking architectural decisions and just software architecture? How have we entered into a system with software and understood the system and been able to communicate about the system? Did you have architectural decision records? Did you use wikis or Word documents or word of mouth? What's it like I remember I did this one time, I loved it, I never did it again. We had a panchayat. I'm sure I'm pronouncing that incorrectly. But the point is we used to find a way to talk about the software. It's just it wasn't done deliberately. So I want to know from us, have we been involved in exercises to document architectures and make our software architecture plain and clear to everyone else? Does that make sense, Ryan? Do you understand what I'm asking?
Yeah.
Now, I guess, Ryan, since you have the con, what are some of the approaches you guys have taken?
We have stuff documented in a wiki, but to say we're diligent about documenting changes to the architecture, I don't think we are. Particularly changes to the architecture. I don't think we're diligent about that.
Okay. It's interesting. There's a tool. I'm not going to look at it today. And this is not one of those, what did our friend call it? This is not, I'm not trying to sell you guys and come back next week for more. That's not what I'm doing. But I didn't plan to cover it today. So I'll tell you what the tool is. It's a tool called Sonar Cube. I've started to use it. And it part of the problem, I think, as well, is out of sight, out of mind. You build the software, you write the code, it works. You write the tests, they work. Writing the documentation may sometimes lag. And so having some tool that could flag your system saying, but there's nothing here talking about the system apart from in the code. There's not sufficient documentation. I think is a big deal. And so tools like Sonar Cube and others that are meant to help you track technical debt, track the building up of it, which is not being covered today. But I think those things are important. All right, and anyone else, how have we tracked our architecture characteristics?
So I've used Sonar before, and it left a gap and this could be that I didn't know how to use it that well, but Sonar did not track the infrastructure very well, and some things a little bit outside of the core software platform. And right now I use decision records. So we just drop decision records in whatever repo the decision is for, or the most appropriate one. And it's not just architectural decisions. Something as simple as we need to pick a library. We're going to spend no more than an hour researching and come up with something, and we just roll forward with that. We have some emails, some team chats, and then make a decision, capture to a decision record, commit it with the repo, in the repo with the change or just before we do the change. I've also used this tool. It's not Archimate, it's the free version. That is the most formal. That one is, I would say, unless you're extremely experienced doing formalized architecture, that one is just like a huge jump because basically you have to drop all the building blocks in place from the business side of the architecture to the infra that you're going to run on, and then the detail of the applications that you're designing.
Can you repeat the name of that last one, the enterprise one?
It is Archimate, I want to say.
Fair enough. So what two things jump out at me? As I mentioned, when Googly made his post, he was both celebrating and then not celebrating architecture. Because our industry has this way of sometimes building, this is all, guys, to be clear, this is relevant. I'm not taking us down any bunny trails. Our industry has a way of sort of building temples out of things that shouldn't be temples. So we would make dogmas out of choices that were made in the past. They may have been effective at the time. And so, for example, if you grew up with architecture being boxes and circles, then that's all you appreciate as architecture, boxes and circles. You don't have any space for the C4 approach to documentation, because that's not what you learn. So we all have to have this ability to be flexible, which is what I love from Googly's post. But beyond that, as now you don't have I don't see a name. I just see HADR endpoint. So I'm gonna call it endpoint for the minute because endpoint is familiar to me and I love it. So
whoops. Yeah, I was doing some work there. It's Hassani. HDR endpoint. That's the default endpoint that you get when you create a mirroring endpoint in SQL Server, which is what I'm doing right now.
Sorry, Hassani, hold on, Hassani.
That's actually Hassani.
That's not Hassani holder. Anyway, let's not be too familiar in my course, please. Hassani endpoint holder.
My bad. I must have pasted that in.
Yeah, that's okay. That's okay. The thing that jumped out at me, I remember having our team write a blog post to justify a decision. And at one point I was called Captain Blog because I was always asking someone to write a blog post somewhere. We didn't have the language of architecture decision records. He was simply keeping track, because as it turns out, if you work with a number of different teams, for your team may be fine with the decisions you make, but another team may justifiably want to know why you chose to do what you did. And so it just made sense, create this repository that can point out, here's the change, here's what to expect. I think a nice way to look at it is an enhanced README, enhanced way of tracking the decision that took place. So as Hassani shared, that it reminded me of us doing that. And so what you have is that formalism. That's it. We need to be careful with the formalisms. For the things I showed today and for the things we talk about, they're guides, they're meant to help. They're not meant to create new religions for us. So as you see it, take what makes sense. And if it doesn't feel right now, you don't need to feel bad about that. So thanks a lot for that. Let's keep moving forward. So we mentioned what is software architecture to start with. We're going to come back to that. But what do we expect of an architect? Take note of this list because it took me a long time to appreciate this. As I had architects on my staff and I was like, what I want you to do, and for the most part, if you don't give a software architect in a software company a clear sense of what their roles are, all they'll do is just be a person whose name is called architect and they'll write code. But more than that, it's not about the title in this particular case. What do you expect when someone says to you, you need to have some time to talk about the architecture? Then you need to have people who talk about the decisions behind our systems. You need to always be analyzing what you propose to build, what you have built, the difference between them. The one on keeping track of trends was a hard one to nail down until I realized how I've been doing it, and some of my colleagues have been doing it for a long time. I think I mentioned this even back when we were advertising this course. I had colleagues who would keep track of when the new languages came out, when .NET 1 or 2 or 3, and at that time would have been 3 or 4 when it came out. They knew when it came out before there were the blog posts about it and that kind of stuff. Today, it may be you have colleagues who keep track of when the next version of React comes out, the next version of TypeScript comes out, the next version of Laravel comes out. You pay attention to it. It is, so though I call that the role of an architect, that's just the role of anybody who's paying attention in the industry. We don't, or I don't feel we have the space any longer to ignore what's happening to the tools we use, the platforms we use, and the context around us. Just from the basis of security, it's important to be aware of the potential incursions that may happen if we don't update our systems. But beyond that, there's better ways of doing things, alternative ways of doing things, things that may allow you to do further things better later on. So an architect or someone in that role is expected to pay attention to those trends. I kind of lump that together with people who are involved in development leadership, who are lead developers or who have command of projects for whatever time period. Along with that is compliance. Compliance is sometimes not a very treasured word, because there is the team or the leadership team, the experts around the company making a decision for a particular way for things to get built, and then there's you writing the code. Who makes sure that the code is written up to spec? But ensuring compliance doesn't necessarily mean that you look at every line of code, but more than likely you put systems in place. I'm sure most of us have pull reviews we work with. So when you submit a pull review, there are certain set of standards that are expected to be present in the code as written. Architects should be diverse. I feel like that's just part of the game today. So even though maybe the core languages you use are C or C++ or Python, maybe you should be aware of, so if you play a lot with imperative languages, spend some time looking at how functional programming works. It only makes sense. The last one I think is extremely important. We'll find ways to touch on that. There's a whole week dedicated to looking at the lean movement, building minimally viable products, and having that business domain orientation. For many of us in software, I'm going to repeat this one in particular as well, so apologies when you hear me say it again. Many of us in software, we lead with our intelligence. Most of us on this call, I don't know that if I scroll through the names, I'm just going to be wild and say everybody here bright. I'm just gonna assume everybody here bright. You know, bright in Trinidad's classical sense of brightness. You know, you're good at writing code. You're good at logic. You're good at putting things together. But somehow that doesn't mean you're just going to be good at what the business needs. We need to be humble enough to know that we need to reach outside of ourselves, understand why choices are being made. And oftentimes when you do it well enough, you do it effectively, it leads to value for you and for your team because you're building relevant solutions. You don't find yourself building something, finishing, the thing being perfect, and then no one buying it. As that happened to me before, let's keep the conversation happy and delightful. Once take a beat to talk about process and practice. So what you find yourself doing in software architecture is, because you can't do everything, you have to find some way for your team to conform to the values you are expressing. So typically, you are creating new processes. So like I mentioned, one of my processes was every time there's a choice being made about which technology we choose for a project, that choice is documented, research is done, maybe a spike for the least is done, and that spike's output is stored somewhere in our backlog and our README documentation. Similarly, practices may be for every bug that is created for our solution. So the solution gone to production, bugs have been found. For every bug, you add new exceptions that will capture that bug. You add new tests that will make sure that the thing that causes the exception is triggered. You add new tests to make sure that those exceptions are no longer triggered. That's an example of a specific deliberate practice we invented to treat with some of the issues you were seeing. And honestly, as much as you could create both processes and practices, if your team doesn't have the space or the time, they just become technical debt. So then having some ability to draw down on technical debt. I keep mentioning this term. I didn't plan to talk about it so early in the course, but it's this technical debt, just briefly, is just this idea that you know a better way to do something in software, but you don't have the time or the space to do it. So you just keep track of it and you go on and do it in the less optimal way. The more optimal way becomes part of your debt of work, DBT, to be clear, to get done, to make the solution better, to improve the way it's built, things like that. So it's important to have this orientation as you build your practice, as you build your software team. I found myself in the role I'm in as a fairly new role, building out these processes and practices using a thing called a playbook. I thought playbooks were brand new because I had never used it before, but then one of my colleagues said, oh, we've used that for a long time. The idea being you have to build these practices. And if you're in an environment where you're kind of low on both process and practice, it turns out to be one of those environments where the brightest man wins, or the smartest man wins, or the man who's been there the longest wins. Find a way to get them to articulate what leads to success and make it so that everyone can follow those pathways without having to rely on an individual to tell you what we did for success. Before I go here to define these characteristics with more details, anyone have any cool processes they can share for their team, how they build things, what they've seen at their organization? I'll go first to give you an example. We this is as I said, we have this thing called a playbook. So every month, my team, we've created a document that describes what's important for the software engineering, what's important for product engineering. So every month, my team fills out this playbook by responding to the questions. Did you reduce technical debt? Did you add more tests? How much closer are we to continuous improvement, continuous deployment? Because that's it. And for me, the process that we created there was every month, update the playbook with what has happened in your neck of the woods. That's one of our processes. Can you guys share one of the processes that you've created or a practice your team has created to help guide the ship of software development?
And we just build projects. We collaborate with other internal stakeholders mostly to build little projects for the faculties. And to see we have a process, really just try to stick with what we know, because it helps us onboard new developers to take on the projects in the future. So we will develop with the stack and technologies that we cover in the courses. So students coming in, inheriting the code base, it's like easier for them to pick up and get running with it. So I guess in that sense, we are limited in that we try to stick with the familiar technologies, because the training is could be expensive.
When you say familiar technologies, what do you mean, Nicholas? Give me an example.
Like specific programming languages. So a student might come and say, hey, so you want to do MongoDB for this? And I'll say, no, we can't do that, because your replacement will have to come and learn that. So while you like that, I would really just stick with whatever is learned in the web courses here. That means when you want to give a contract to your replacement, very easy. All the students who did year 2 web already could go and get up and running. We understand that could be troublesome, because there may very well be a project where we need a MongoDB. So we still try to keep open-minded, but as much as possible, we stick to what's familiar.
Very cool. Nicholas, I'm happy to hear you guys have an interesting model. Are you saying that in your department, so this is the Department of Computing and Information Technology, other faculties reach out to you guys to build projects and build line of business solutions for them?
Yeah, every now and again. It could be we follow them to finally a project, or sometimes we have something bigger. Yeah, we collaborate often, and even some external stakeholders, which we might have to tell them maybe it's not the best fit for us, because we can't build the enterprise system with just a group of 3 students.
Right. Fair enough. All right, cool. Anybody else processes or practices that they've been using?
One that I recently got some experience with is meeting. It's not necessarily everybody get together, it could be async, but we call it ship room, and it's basically checklists and throw up a flag for anything and everything we need before shipping. which is, is all the pipelines running green on the release branch? Do we have all the document updates staged? A feature flag needs to go on or off. Any little thing that needs to happen before the day we pull the trigger and start to ship. We have that meeting every week. And the week before, the week before release, no, actually the week before snap of the code for release is the craziest. Because just having everybody together, typing in a chat or just talking about what we need to do, and people asking questions usually throws up a lot of flags for a lot of little things that might get missed, or a lot of little things that somebody new might miss, but somebody with more experience in either the code base or the process might just know to ask. So that's been an interesting one that I've seen recently. That is kind of cool.
Sunny, I like that a lot. Yours sounds, even hearing yours, I'm sure I'm gonna steal some of it. But we have some in my day-to-day daily shop at iGov. We have some launches coming up, and because it's cross team, I don't know how they did it before, but we created a couple update groups. And one of the things we made was a launch plan, like a NASA launch plan, like a launch sequence. And there's like a whole NASA feel to it because we're a bunch of nerds. But the idea of one, surfacing the elements of the sequence across a bunch of teams really helped us catch when we were probably going to push something out that wasn't ready, that we may have been missing documentation. In my environment, you're not just pushing the code out, you need to have communication that goes out to the nation. You need to have stakeholders aware, you need to do training. So, and that's not just my environment, that seems standard. But that thing of the comms team is aware as well as the ops team is aware. I shouldn't say ops. Any Gen Zs here? The operations team. All right, guys. The operations team needs to be aware, along with a bunch of other stakeholders. That means write it down. And I like what you just said. You're reminding me the guy who wrote Good Strategy, Bad Strategy, Richard something. He was in an interview and he was saying it's very, very effective to sit in a room and have people do a simple version of what you said. Have people ask not just what do we need for success, but if you had to envision failure, what would that look like? I maybe mix up my interviews. I may not have been Richard, but it was a very effective question, and I like that idea a lot. Anybody else? Any other processes? I want like one more name. Maybe I could call Sadia. Sadia, anything to share?
I haven't really been involved that much
Mhm.
in the processes. I'm more of like a technical customer support specialist, so more like the testing aspect of the software.
Right. Well, let me ask you, how do you, when there are updates to the software, how do you get up to speed to know what to test?
Oh, we do regression, a regression on the entire system and just test everything and make sure everything looks good and there are no bugs.
So sometimes you are not well liked is what you're saying. Sometimes they don't want to hear from you is what you're saying sometimes.
Sorry?
Sometimes they don't want to hear from you at all when you
Yes,
problems.
that's correct, yes.
Fair enough. Thanks very much, everyone. Let's keep moving forward. I want to lean into more on these software architecture characteristics. Really, operational characteristics as listed here revolve around what it takes to give this software, this application, this solution, the seal of approval is working fine. Some companies have very specific measures on availability and performance in particular. Availability being that the application is literally available for service. You may have seen, for example, if you use a cloud application from like a Microsoft or Google, that their service, say it's Azure storage, has 99.9949s or 5 nines availability. Some other services have 5 nines, 99.999, meaning they're down for minutes in the year. That is very hard to do in practice. I shouldn't say in real life. So some companies do it, large cloud providers do it. But when you are delivering a service for maybe a local enterprise, an enterprise in Trinidad, or even for government, when you say, I will deliver this for you, and we ask you, what's your level of availability? If you commit to 4 nines or 5 nines, you need to make sure you have the appropriate redundancies in place. That's in high availability territory, which means it's not a single server most likely deploying on its multiple servers, multiple database instances, which are helped by cloud. But if you're in environments, let's say like financial services, where they're still learning to trust cloud, then you may need to find ways to deliver that yourself, which means increasing your complexity. Similarly, for performance, I mean, I'll never forget, I built this app to track elections. And I was very proud. My app handled 1.2 million hits. Somewhere in my blog. The problem is I probably only had about 1,500 actual persons on my site at the time. I wrote the code so badly. I shouldn't be so hard on myself. I used polling when I shouldn't have used polling. And what that resulted in was a really poor performance in the application, because I didn't test it with 1,000 people on it. I didn't have the approach to test like that back then. So I learned the hard way that if you have a website that polls every 10 seconds to a web service, the web service will very, very quickly, if you have a number of persons who just load up the site looking at election results, your page going to suffer. So being able to describe the required performance characteristics and validate it is critical. And of course, recoverability, that same election site I had built, this was before cloud properly. So cloud was around, but everybody didn't use it yet. We were using a regular web host. So all we had was the ability to scale up, meaning make the host give us a larger and larger machine as opposed to giving us many more machines. So if that one instance went down, then we had to wait for it to come back up. It was a horrible thing. Whereas things like reliability and safety, I don't think anyone in Trinidad in particular can escape questions about safety and cybersecurity. It's become hot topic. What are you doing to ensure your systems can handle the attempted incursions and attempted compromises by bad actors? At the national level, we have the Trinidad and Tobago Cybersecurity Incident Response Team, which organizations can reach out to and ask them to do a penetration test of their systems. Let me just pause here. I want to mention that one in particular. I assume most of us operate in and around Trinidad. Show of hands if you've never heard about that arm of Ministry of Digital Transformation or National Security, the Trinidad and Tobago Cybersecurity Incident Response Team, TTC CIRT. Anybody here never hear about TTC CIRT? Oh, wow. All right, I take any one. Hilam. So the rest of us have. I'm not checking chats properly to see. Okay, so a few of us. So I see, I see your hand.
Hi, Ewan. I don't know how to raise my hand, so I'm being rude and just talking. I've heard of it, but I didn't know they did stuff like you could request penetration testing, for example.
Yeah. Yeah. Thank you everyone for sharing. I know it could feel a little awkward to say I never know about that important thing, and that's okay. Every application we push out, every web application or any kind of application, we request testing and verification from a team like that. Now, you don't have to use TTC, so you can use any organization, but the point is when you have high stakes environments where users' data is at play or you need a system to not be compromised, then you need to put things in place to ensure that the question being asked by the characteristic is being answered appropriately. So that's one of the ways of getting it answered. Of course, things like robustness means how well it can handle bad data, how well it can handle when people submit bad data in, either mistakenly or they do it deliberately. And scalability is one that for my career in messaging, which a few of us, people from Telios have been here, I used to look at Telios before, scalability was just a part of our bread and butter. We had to figure out how to build systems that could handle a high scale, high throughput. And scalability is a question of throughput. I think it's important for all of us that try to get experiences that demand that we learn all of these operational characteristics, the manner we experience with it, it might mean that you have to not just rely on your day job in terms of writing code or building systems. You might have to find an open source project you could monitor, build your own thing that allows you to explore these things with tests and with just engagements that maybe your day-to-day mightn't give you, but it's really critical to understand it from off to allow you to deliver software with greater and greater degrees of capacity. So beyond operational, the structural, which in my mind, it's the Lego blocks part of our software. How well can you fit pieces together? I think, so Nicholas and I met before, we were talking about magic numbers as an anti-pattern. I remember one time we were building an application and somebody, I wouldn't call any names, they needed a default number for something, and so they used number 5 just as a value for the variable. No rhyme or reason. It's just like let's go with 5. That number stayed there and got to production. It was a horrible thing, but we figured it out. We found it. I don't know how long it took us to find it, but we found it eventually, and we made it a configuration item. Configurability relates to that. Hassani mentioned a little while ago feature flags. I think feature flags are a big deal for rolling out updates, making changes to software that you need to put behind a limited number of users or for a limited time frame. I like that a lot. I won't go through all of these. I want to touch on maintainability. When you work in a team, being able to have a high degree of maintainability, and I would add to that. The word in my mind is rewritability, but that's the wrong word. It's Martin Fowler has a book about it. Refactoring, there you go. Writing systems that are easy to change when making changes are easy is like the goal behind object-oriented programming, really. It's not the only form of programming, but one of the things I've heard and I've seen in practice is you want to build your solutions in such a way that making changes are easier to make than hard, which might mean you build the system more simply than you could. Anybody here still delights to put a ternary operator into their code just because it looks beautiful? Any ternary operator users here at all? You know what a ternary is? That's when you write like if you're writing a variable. Let Nicholas raise his hand. Nicholas, it can't be so. For A equal, well, if something is true, then it's B, else is C. Our code looks so beautiful. Look at that. Guys, less ternaries. I know it's cool. You learn that in school. One line doing that, less. Because the next guy has to think about that line of code a bit long to figure it out. Now you could write it code how you want to. I wouldn't tell people don't write a ternary. But I will say try and ease up. Sometimes we like to make our code look beautiful, feel beautiful to us, but nobody else could support it as easily. That's at the heart of maintainability, and it's critical in terms of software architecture. You can use things like linting to reduce some of that. For example, how your programming style gets standardized. The use of particular conventions is important. Anybody doesn't, when I say linting, we don't know what that means. Anybody never heard the term linting before? That's a horrible thing. People don't like to say I never heard it before. But linting is the use of coding conventions in your IDE, like Visual Studio Code. I should know more than Eclipse, but there are quite a few others that will tell you, a developer, when you are coding outside of the convention. It's very, very useful, and it helps us avoid some of the frustrations with trying to figure out somebody's coding dialect in an organization. When you're writing code by yourself, write it how you want, but in an organization, you want to maintain certain standards. And of course, there are cross.
If I could
Sure, Hassani, go ahead.
interject, because yeah, LinkedIn is a one that I've seen it in certain projects be more than just run the linter in your IDE, but I've had projects where the catered check-in pipeline will run the linter and lint your code for you, and will not commit the code that you submitted, but commit code linter the way that the repository demands. So yeah, like you said, it's really important. So much so that some people don't care what code you submitted and will lynch your code for you.
I kind of, as you mentioned, pipelines. Again, I would not have touched on that today, but how to ask this in the way that people will respond. Guys, to be clear, in a class like this, it is not a make-out class. It's not a class to be like, oh, he don't use pipelines, he don't use Linton, he's a garbage. We're all here to learn together. And I'm just curious, anybody here, oh, and I could raise my hand for this. Anybody here, you do not currently use automated build pipelines? I could put my hand up for that. I don't currently use automated build pipelines. Anybody here similarly, you're not using it for any projects? Ikechi, don't be like that. We're trying to be a safe environment. All right, we're working on it, Ikechi. We're working on it. I'm happy for your response. Yeah, the reason I'm mentioning that is once we establish, I'm going to come to that shortly afterwards, you know what? I'm going to come to that in a little while. But once we establish these characteristics, so we have language now, right? Some of us may not have had the language. Is the application accessible? Is it usable? Does it conform to the privacy and legal requirements? That's language that actually we may not have properly had. We may not have been able to say, for example, to a manager, I'm not finished yet because I have not done a compliance check. You may be teaching someone in your team about that because you are now the one who's pushing to understand deeper and deeper about software architecture. It's a very big deal. Once you get the language, you can then follow up the actions and the practices. So it's actually very, very important. We kind of appreciate that this thing extends way beyond, I feel good I have one practice or the other. As it turns out, you cannot have it all. If you go back to the list, you could tell yourself, my application will be highly available, performant, recoverable, reliable, robust, scalable, it'll be configurable, all these things, all through the end, it'll be all of those things are very high mark. Few applications have all of them. What you actually need to do is make certain decisions about how the application will grow, what you need to do right now, and that's why technical debt forms. If you said to yourself, my application should have all of these things, and very easily you could go ahead and take a note of what you need to have. You can't do everything at the same time, and you may have timelines for deployment. So I mentioned that we don't have CI/CD. I could say that I'm not worried about that. But we're on a path towards it. We could have simply said, just push everything out to production without having the appropriate automated test in place, but we've been problems. So we have to build our way towards there. And I think like many of us, you may be in a place where either you didn't even have the language, you didn't have this notion that you could do that. But now that you have the language, you go away from, if you were to stop today, if you were to stop right now at 6:40, stop right now, 5 for the rest of this course, this class today, you go away knowing I could build towards those things. We actually do touch on that, on how you build towards it, what makes sense to do as soon as you can, what you could take a little step back on. And so we are, and in my shop, that's exactly what we're trying to do. But at no point you can have it all. So you have a conversation as the architect or the architects in your team. Here are the sets of characteristics we should be going after. It mightn't be high availability for you. You may not have a need for very, very many users to start with, but it must be very performant. You mustn't take forever on any given request. Your databases must be well indexed, for example. I won't cover indexing in a course like this, but it's an example of one of those low-hanging fruits for increasing your application performance. You may need to do that because you've identified this thing must work blazing fast for who we're trying to get it done for. As an example of you make your choices and then you go after what you consider to be least goods. For you, security might be the thing. You cannot compromise on users' data. So you use appropriate authentication schemes, appropriate authorization schemes. Again, we don't have the breadth to go into every single way you achieve the various characteristics on the board. But once you identify the characteristics as being critical for you, you go after it, and typically what happens is one characteristic comes along with others. It pulls along others, which is great, but you establish your priority list and you press forward. Right. quick little step back, architectural thinking and the role of the software architect. So I saw this in foundational software architecture, and I liked it a lot. It's separating the idea of traditional architecture before, which was, I tell you the style, I tell you the characteristics, and you go off and there's a big separation. Iterative growth and development seems to have been working really well for industry. Those who've been having success, they haven't had strong barriers between the people who are coming up with what the characteristics should be and getting it executed inside of a software solution, which means working hand in hand, working very closely. There's no notion of a architect sitting in some room sending out missives and letters for the team to follow on. Instead, it's working closely with the team, analyzing outputs, comparing the results of tests for solutions that have been proposed, and modifying as you go along. I actually heard someone say in a meeting sometime recent, oh, we'll do waterfall for this first part of the, and I shuddered. I was like, why me we'll do waterfall? Did let's say that? But I had to kind of step back and allow them their space. For me and for teams, I don't make any such recommendations at all. Find a way to have the decision makers around characteristics closely be aware of what's happening when the implementation happens. That's what's critical for me. And this is just repeating what I said. Effective modern architecture is iterative by design. Building complex systems means software solutions can at times not see the reality of the world they meant to operate in until they get out of the safety of the development environment. It's so true, and it's something we need to, if we're aware of it, we should build our teams accordingly. This is something that you struggle with in terms of software architecture, especially as you try to get better at particular areas. Many of us in the call, maybe we're still there, we would start off writing a lot of code, plenty code, and then realize, oh, I think I like storage more, or I think I like front end more, or I think some aspect of development, I think I like Web3 more. Then you get into those areas of specialization. But the more you do that, and as you specialize, you find plenty of stuff you just don't know. So what you tend to find yourself doing is balancing, especially as you push into, so on the role of the architect is a leadership role. So as you push into leadership, you might find, like I think Ryan said it at the very start, he said he divides his days between criticizing other people's code and writing code himself. I have no doubt, because I know Ryan for a while, I have no doubt that Ryan also criticizes himself a lot. So how do you have to balance it really? The best way to say it is, for someone involved in architecture, you have to deliberately try to find areas of specialization. And I mentioned a while before, you have to expand what you consider to be a breadth of knowledge continuously. A good way to do that is attending conferences, and not just the keynote of the conferences. So not just watching Google I/O for the keynote or Apple's conference for what they say about the new devices, but the actual stuff that comes afterwards. Microsoft Build comes along, the sessions that are focused on technology platforms. Those represent some of the ways you can grow beyond what you know in terms of writing code. And there will always be some broader things you just don't know. So for me, I think of it more like, what's my image? More like this. Back at when I was at Telios, we created a thing called the Developer Ranger program. I think it was because I had seen that show with the waves and the surfers. But anyway, they were climbing mountains, that kind of cool stuff. Nevertheless, it's this idea that in software, it's not one mountain you climb to become this expert. It's not this mountain you come to become, I am the architect of all things. Remember Matrix, there was one architect? That's how you know the show was a lie, because there's just one architect. But as it turns out, any of the areas of specialization can find themselves being very, very deep in terms of mountains, from front-end frameworks, building your own front-end engagements, building your own front-end tools, to appropriate ways to build services and microservices. Just even in preparing for this course, there's a notion of service-based architecture, service-oriented architecture, and microservices. All distinct. There is the plethora of data technologies, this quality assurance, all of those represent potential mountains. And so the balance is that perhaps you have familiarity with a number of them, but you become really good at a few of them. And that becoming really good allows you to give yourself more and more challenges. I think the big deal is that if you find yourself, so remember this course is for this developer's path. And one of the things I would have said into the university was we need to find a way to help developers perhaps potentially accelerate their growth, accelerate their career. And one of the key things that is you have to give yourself hard things to do. I mean, you would have heard it said, and maybe you didn't really appreciate what it meant by challenging yourself. But if you find yourself in the trap of someone coming to you, and I don't want to pick on WordPress, but they say, come and customize this WordPress solution for me, please. And it turns out to be writing a couple plugins and it's the base WordPress. That's a cool thing to start off with. But you need to build your own systems, build your own platforms, build your own mobile solutions that do more than present data on a screen. That's where the work is. And as you build that capacity, you actually become a guide for others. And that guidance allows you to really grow. Alternatively, find people who are doing cool things that you would like to do and join them, either by joining their company or just working alongside them for fun, having a good time. It's actually critical to build your expertise in our world. You have to do hard work, things that are hard for you. Just like climbing a mountain is hard, unless you're like some kind of a hero and you just climb up mountains, you do a marathon in 4 hours and then do it in 2 hours. If you're that kind of person, then this probably doesn't matter. But for the rest of us, you have to actually build our muscle by doing hard work. Even if that's the case, and to be clear, if your company creates this designation for an architect, don't get in the trap of thinking all you do is design. All you do is design documents. You learn C4 as a way of doing it, or you learn ERD designs, or the very old one. I can't remember what it's called right now. And so you're telling yourself, I'm just the designer. You need to be writing code. If you're not writing code, you kind of create more and more distance between yourself and the team you're creating designs for. And you find that your recommendations aren't treated in the same way. So it's actually very, very important to do that. And yet, if you are an architect, you are a lead developer, you have more concerns than what gets to production via the code you write. So avoid being the person who everybody's waiting on because you had 4 meetings, and this has happened to me. You had 4 meetings, so the particular critical change that needs to go to production. And this happens in smaller companies, smaller teams, teams of 2 or 3 or 4. You have a number of roles being executed by the same person, which could lead to bottlenecking. You need to find ways around that. Finally, of course, not because you pursuing the land of expertise means you should separate yourself from people in your teams. So it's avoid becoming the person who hides away in a cave and you emerge with the best solution that nobody understands, nobody could support, nobody could make use of, or if they do, it's very frustrating. Right. Before we take a little break, I found this quote and I think it's important. It's also the stuff that today you can't really hand off to an LLM. I saw the CEO of NVIDIA say, in the future, everybody be a developer. Fine, maybe true. So sure, the LLMs will help you write really good code, but software architecture is beyond the code. And so somebody, maybe there'll be a time when it's purely just machines writing the code, building the architecture, making the choices. Somebody has to say what's most important now and what are the trade-offs we'll make now to get our systems up and running. To kind of end that particular point, what's semantic coupling? But when you have dependencies between the systems of building, it's not just the technology, it's the business practices. And sometimes somebody who says, I need high levels of security, they don't understand that they're going to compromise how well the systems will perform. That's where that comes from. Or my system should scale to handle 10,000 requests per second, but that costs you many more VMs that make sense than you can afford. So there's that trade-off. And so if you actually need to support 10,000 requests a second, maybe you need to find a way to implement exponential back-off and retry, because you just can't do that right now, but you need to find a way to communicate with your users accordingly. Nicholas, I see your hand.
Yeah, I was wondering on that point, because sometimes the end user always asks about security and struggle. How would I even answer the question the way they'll even understand? And secondly, is it possible that security also could trade off usability because we all love using the two-factor code and that kind of stuff?
Right, right. I mean, it's funny. Security, as an example, is thankfully these days much easier to justify. I'll give you two examples. One, though our industry is a bit of a seesaw, the pendulum swings in a few ways. A while back, good advice was don't try to do everything in security yourself. So for example, if you're using OAuth, don't implement OAuth yourself. Maybe you can get a provider to do it for you, or you could use standard libraries. Nowadays, when I hear somebody saying, no, do it yourself, the balance is we're pursuing standard security approaches. I like the example you gave of 2FA because there was a time when people was annoyed. I had to check my phone for another token, but now it's more middle of the road. It makes sense. People are more concerned about their data and they're willing to compromise along with you. And it's not even compromise. They're willing to make decisions that protect their more valuable resource by trading a less valuable resource. So whereas they might say, you know what, it will take users 20 seconds to log on as opposed to 15. That 5 seconds is giving them assurance. So it's being able to have the conversations that work with the users, with the customers, to understand their business needs as primary. And from that, so the business need might not be perform in 15 seconds. It might be ensure that customers maintain a high degree of confidence in your system. Oh, if that's the case, then yeah, we're willing to find some way to trade. And that's where the trade-offs come in. I love this concept of semantic coupling, because the more experience we get, the more we do reading and learning and watching the videos on YouTube, the more we can catch some of these issues earlier. The more we can say, hey, you're asking for X, but X actually impacts Y. And we may need to at least understand that and allow them to take a step back from what they're asking. Fundamentally, I see architectures being software architecture today, for the most part, is very business driven. It's funny me saying this now. I feel a certain degree of growth. If you knew me growing up in the past, the highest goal was technical excellence and nothing else. I mean, that sounds good to say, but there's impacts. There's an impact on spending all the time making a specific component work and not enough time understanding why that component was important. Developers may hear this and think, oh, you're giving up technical quality, and that's not it. You're recognizing that maybe you could arrive at good quality and leave best for later on. What does that mean? It might mean that you are using a regular database as opposed to whatever the industry is saying is the fastest, best database. Using a database as, I like the example Nicholas gave. Somebody comes saying, let's use Mongo. Mongo sounds cool. It's nice and NoSQL, but maybe we could get the same features inside of our Postgres database. Maybe. It's that willingness to understand that if we were to pull the team into some new technology and we don't have proper support for it, to set ourselves up. You know, it's balance, and it's something that allows us to grow as our customers grow. And that's critical. If we alienate our customers, if we pursue technical excellence at all costs, then what happens is our customers find that you're not really hearing them, you're not able to deliver what they need. And they don't use you as frequently. If our customers can realize that we are well-placed, we're trustworthy, we're delivering what they need, then they're more confident in giving us more and more work. And I mean, I've seen that has played out for real. Customers would have come to our company for a simple, straightforward solution, seen us deliver it, and then because we did it in a reliable way according to their needs, they were able to give us more work. So it's critical and a strong way to look at how to build your career. Guys, before we take a break, let's look at these questions. Let me get some answers across the room. First one, what's the primary goal of architecture thinking in software development? Any answers across? I don't want to read out of the answers. If you have the answer, you can just unmute and shout it out. Looking at the first question. I mean, if you do unmute, I might just call you. Just because we're all friends here, friends here having a good time.
C.
There you go. What's the primary goal of AT in software development? Directly writing code, managing software developers, ensuring the architecture aligns with business objectives. Thanks, Akechi. All right. Which metaphor is used in the architecture thinking section to describe gaining knowledge across different tech areas? That was this.
Go.
Go ahead, Nicholas.
B?
Yeah, I'm gonna go with B, although I did mention running a marathon a while before. That's because I'm a little bitter about hearing somebody take 2 hours of their marathon in real life. That has me a little bitter. But yeah, I liked using the mountain ranger imagery. How should a software architect approach the trade-offs between scalability and cost?
C.
Yeah, let's go with C. Balance based on, once the answer starts at balance, you're in a good place already, based on current and anticipated needs. And finally, which of the following best describes the relationship between architectural thinking and detailed design?
It's architecture, also design, so it's broader.
Architectural thinking focuses on broader system aspects than detailed design. Yeah, man, B, simple B. Guys, let's take a few minutes break. Let's come back at, my time is 6:32. Let's come back at 6:40. But in the meantime, think about this. We'll come back and talk about your experiences on trade-offs you may have seen. Yeah? So we'll take, like I said, it looks like to be 7 minutes break and get back into the game really quickly. Yeah? Cheers, guys.
Are you still there?
Yes, I'm still here.
Can just pause the recording. Meanwhile, so it's a little easier. That was pretty good.
That's a really good idea. Hey guys, and we're back. Everyone is fine. I had a chance to look at some of the responses to the survey we sent out, which is really, really nice. Nice to see people's desire to grow really and to engage the content in a way that will be beneficial to them in their career. If you didn't get a chance to fill this out, please do. I'm going to send the link again in chat. It really helps us understand how to proceed with the other weeks of the course and for further offerings of this. I see Derek had to drop off. Thank you, Derek, Angie, and thanks to all of you who would have joined so far and your teams. This has been going really, really well, to be honest. And I think I'm looking forward to how this unfolds. I do like, so for example, hearing from people like Ryan, Anikechi, and Hassani, I love the idea that what we could find ourselves building quite accidentally is a place for our developers to hear from familiar voices, familiar songs, see faces who look familiar to us, who could tell us interesting stories about how they build things in their career. If that's certainly what helped me as a software developer coming up, and really part of what this course is doing is passing that on to others so they can actually do the same. Right, maybe can anyone share an example of a trade-off that they had to navigate between performance and cost? I know it feels a little vague, but maybe you had a chance to think about it. What jumps out at you?
Well, it's a simple one. So, speaking of databases, the application that the BUV app that we run and support essentially lets you search what programs you could register at UV with your CAPE and CSEC subjects. But because program requirements is so complex, like only a graph database would have been helpful in performing such a intense matching query. So we had a graph database, but in looking to deploy it, there are almost very little offerings of managed databases. So, you have RDS and all these ones, but all of them are really relational databases. You don't find managed graph databases often. If you do, they're just way more expensive than your regular. So we had to just basically go with a VM. And the only thing on that VM is our graph database. And I guess that's a bit of a trade-off. Imagine the managed service might be better. But the query is really not as intense anyway. But it does take up a lot of memory. So even then we couldn't have the smallest VM possible. So in a sense, we do have a trade-off there until we figure out how to run this thing in a container, maybe.
I like that example a lot. I think because you started off, when you started talking, I heard a data problem, a data challenge, right? Data complexity or a data issue. So I thought the trade-off was going to be on that side, but it turned out to be a much more, I wouldn't say simple, but regular trade-off, which is the use of a VM, how to use a VM effectively. It reminds me of, I was doing a database for, not a database, sorry, a server for a geographic application. And so we needed to use a special kind of software, special GIS software. Now, my orientation was to provision a real beefy database. I keep saying database, real beefy VM, because I mean, that means the server running in the VM will execute results extremely quickly. But the application, because it was a POC, I didn't need that. I just needed it to work reliably. So I was able to analyze kind of what the number of customers we're going to get, the number of requests we're going to get, and scale down the VM so that it still delivered the value, but I didn't need it to be a beefy high performance one. I just needed it to be up consistently. So what that allowed me to do was, instead of thinking have one big VM, just set up a VM that lived in such a way that if it went down, another one was available really quickly. Either because I could spin up one really quickly, or I just ran them in parallel if I needed to. And I almost never needed to. So it's an example of, oh, I want this thing to perform well, but in the context of the business, I needed it to be available more than perform. And this is how I was able to get that done. Anybody else, any other stories like that? I just want to call all the names I see, but people feel like I'm picking on them. I don't want to pick on people randomly. Carisha, any stories you could share at all? Oh, look, Ryan, there you go. Carisha, go ahead.
Hi, Owen. Long
Sure.
time listener, first time caller.
Sure.
Why things that's interesting to me in this trade-off between performance and cost is that typically people might think of the cost as the infrastructure cost, but there's another bigger cost that you might have to consider, which is developer cost. Developers cost money. And sometimes you might have to say, okay, if I have to get this application to run faster, then I have to spend more man hours on it. And if these developers costing me 500 US an hour, then it might not be worth it for me to do so. So the developer cost is a significant cost inside of that particular trade-off as well.
I like that because you also elevate it into a risk game as well. You very easily make it, what happens if this developer becomes unavailable, or this team becomes unavailable? It really does make you, once you start adding those characteristics to the conversation, you begin to move your decision making in the direction that makes the most sense. I like that a lot. Krisha, one more from you.
What if I don't have an example?
Well, then it's good to hear your voice, Krisha. Good afternoon. Thanks for coming along.
I don't have a trade-off example per se.
I was actually thinking about the processing costs. So I was thinking about a document management solution, and so maybe a recommendation that you use some fancy software to do the document flow processing, maybe some RFID or whatever, but every document needs to therefore be tagged with that RFID. So it's like, should we spend the money to tag every new document with an RFID tag? Or perhaps have the system work a little bit slower because humans are getting into maybe updates manually. There's a nice kind of way to think about how that works in terms of the humans who are making updates to a system manually versus it happening automatically. If the processing of documents and the updates a human does takes up so much time that it slows everything else down, then maybe automatic processing via some technical solution like RFID or some other kind of image-based solution may make sense. But if it doesn't slow things down because in the workflow, that's just one piece of the workflow, then maybe that cost does not make sense. So we enter that realm of when we are having these trade-offs, it's really conversational. It's let's talk about it, let's see what we're trying to build, and then let's move from just theory and ideas about what's best right into, well, let's make some choices that can help us be most effective, deliver the best in terms of value and system behavior. Thanks a lot, guys. That was a really nice conversation, a really nice way to think about the challenges we're looking to get sorted out. But now let's move into a few core concepts. Not a lot, not a lot. There's actually one I really want to talk about, but I'll talk about the others too because they're important to know. So most of us would know about modularity because maybe we have a strong object-oriented background. We did object-oriented programming. We use languages like C# or Java or Python or even JavaScript on Node. You use that kind of stuff. So if you learn object-oriented programming and so modularity, grouping code in a way that makes sense, this is something that comes naturally to you. You want to explore that some more using the terms cohesion, coupling, and my new favorite term, connaissance. Right? We'll come into why in a little while. Anyway, so we know these terms if we've done any basic development, but just to refresh our memories. Cohesion, it's to what extent parts of a module or a class should be maintained in the same module, how related the parts are to each other, and whether we should be pursuing that or not. Cohesion is something you want. You actually want high cohesion. Whereas coupling, and that term is what you use, high cohesion. Coupling is the other side, where the degree of interdependence between modules. So modules here, use modules to step in for a class or for a method or for some artifact that is a unit of delivering work or software value. A measure of how closely connected different parts of the program are. So typically you want low coupling. These are not, don't think of these as rules that should never be broken. Just think of it as guidance. I'm going to be honest with you. Before I started building this course, I had never heard the term connaissance. You know what it's like? It's like that term when you put two strings together. What's that term again? Concatenation. It's concatenation. Why use such a huge word to mean put two strings together? And here we are. Another C word, connaissance. It's a metric to assess the complexity caused by dependency relationships between different parts of the program. We're gonna see it in a little while, but for me, it was new, and I was happy to find a very new thing, though I've been architecting solutions for a long, long time. To explore this, and before we go into the discussion, I actually have a bit of code to demonstrate both of the concepts. So let me pull it up here. Get this window across on the other side. So I have this ticketing solution, right? It's for a company that does, it's a very simple solution. And this first version demonstrates, is this my ticket solution? I think it is.
Hey, can you increase Zoom, please?
I can, but let me make sure I have the right window open. We'll come back to tickets because this is the next week. I rush into class. There we go. Close this guy. And here we go. Zoom in is what Nicholas is saying, because be reasonable. Where's my Zoom?
You could hit command and equal.
Guys, I come from a Windows background. Okay, Gechi? Thanks, Gechi. Because it's still not 3 minutes. Right, can you guys see? So I have two, I'm working with two projects here. Contact manager, like literally for managing contacts on your phone or whatever. It's very, very simple. I have the first version, which is helpfully called Pre. It's a Node.js solution. Anybody here not familiar with Node at all? You've never seen Node before at all? You've never seen JavaScript before? No, it's not a bad thing if you've never seen JavaScript. Nobody's going to insult you at all. You know, so let's pretend we all know it. We're going to have a good time. So we wanted to talk about things like cohesion and connaissance and coupling, right? So we wanted to just take a look at this class, how it works, right? Module is better to use in Node. It's a regular site being built here. We're using Express to display the site, but really and truly, the routes are what we care about. So if you needed to see the home page, it's going to handle it with the default route here. And then to make a call across, creating contacts, it's done all inside of this method body here. And similarly, inside of, for getting contacts, it's going to do it inside of the body here. And then let's be hosted, we're good to go. In terms of storage, contacts as a new map inside of this class, right? This is a small class, but you could also call this a small ball of mud, right? Everything is happening within this one class. Typically, if you needed to maintain this, you have to jump in. I keep saying class is the wrong word, let's say module. Everything's happening in this one module. I would jump in here if I need to make a change to the storage. I would jump in here if I need to make a change to our contacts are saved or processed, and similar for returning, right? I could be a little bit more worthless. Instead of sending a file, I could have actually returned everything inside it to make the point that this is everything all in one, right? So I built this because this actually feels familiar. It feels like what you would start with when you're building a project, just to see how things look and feel. But when you're building it to meet some of the goals, and let me go back across to architecture, some of our characteristics. If we had to pick, and let me throw it out to you guys, if we had to pick a characteristic that we wanted to address looking at that class, what would it be? So we have operational characteristics, we have structural characteristics, and cross-cutting. I'm going to stay on structural because there's a particular place I want to focus. Which of these characteristics we think is not being paid attention to at all for that, just looking at this class? I keep saying class, I should say module.
Is it maintainability?
I mean, I would go with maintainability too, right? I would, just looking at this, maintaining this could easily become a nightmare. Ikichi, why would you say maintainability?
Yeah, based on what you started describing, where you could kind of pull some of the functionality out, separate it so that if someone has to maintain it, they're not going through, let's just say this was bigger, you added things like telemetry, you're not going through one module that has everything inside it to kind of find a place that you need to modify. So kind of having some separation will make it easier to maintain in the future.
Yeah, so, and it's just as this is a simple example, but I think it's spot on in terms of maintainability. I feel as well it's use of reuse jumper here as well, because if you needed to reuse anything here, we're going to, you can add a referencing time module to make it useful. So those two represent examples of that. So I was talking about cohesion and coupling. This one may not be the best example just yet, but let's take a look at an alternative way to get this done. If you were to change how we build this, right? We might take an approach like this. First of all, you may already recognize the separate folders as opposed to there's just the one public folder here. And inside of here, we have controllers that will pass things on to cause the services, then use our storage module to allow us essentially to make this much easier to grow and change with. So same initial functionality, right? It lets you manage contacts. But you can see here, instead of all the code being defined in the app.js module, it's being defined inside of the contract controller via these specific methods. If you take a look at add contact, you would see it's actually using a contact service. Now, from the time you see this, depending on how much experience you have, you may recognize, I've used a repository pattern, and you might be a little concerned about that. Just having the awareness of a repository pattern is what we're going for in this particular class, but we're not going to explore whether you should have repositories or not, how they should be executed on. It's just the fact that you've separated the concerns from what was a very basic approach before, where everything was mixed into one. It didn't make sense to measure coupling versus cohesion because it's all pretty horrible. It's that bowl of mud. Now you can ask questions about the ways to approach separating a contact controller versus your service, which this does here. So it goes further. For storage purposes, the service is using a storage module that now, if you wanted to change, let's say you did a POC just to show the thing working on a screen, and now you said, let's move away from POC, we want to get to store this somewhere else, you would change the storage reference here, and then you would go ahead and find or add a new folder that does storage away from memory, perhaps into some relational database. Let me pause there for a sec. Does that make sense? Does that jump out at anyone? Any questions about that?
Suppose in a way, it might help with portability, because if one party system talks to a specific type of database, then changing a database will it affect those other parts?
Yeah.
They
So
could port it to, but
no, I agree with that. That's a very good point. We give ourselves a lot more options by taking a different approach. Now, the funny thing is, in building this out, I do like to emphasize, as much as writing this code would have been fun to do from scratch, I use our LLM to write this. And I'm seeing us go to a place where you use your LLMs to reason about a system. Now, I'm gonna be careful about that. LLMs can't reason, at least not, no one really says that properly out loud. It's not that LLMs have thought and they're geniuses, but they help you reason, because as you engage this thing and you ask it questions, it can help you come to a sense of what you are going after in terms of characteristics and attributes of your system. And I found that to be very, very effective. So let me show you what I mean. Jump into this discussion here, right? So I'm not going to go through it. It's pretty long, so I'm not going to try to have us read through all of that. But I actually said, I want to talk about this stuff. I want to understand this thing some more. Let's use an order processing example. So the agent was able to create a story around order processing. Imagine an e-commerce platform that processes orders from customers. System takes orders, verifies availability, processes payments, updates inventory, manages shipping. So it starts with this idea that it was monolithic, and then we want to expand that. So the thing that I'm emphasizing here is we may have spoken about this and had a pretty decent class today talking about elements of modularity, which would involve cohesion, coupling, and connaissance. But finding a way to drill deeper than the one example I gave, or to take examples from your own work context and apply questions. How do I measure connaissance? What kinds of connaissance are there? Because connaissance is a very broad thing. It gives you more space to consider. So that's one of the things I wanted to emphasize, that as we look at this content, we read the books, we see the guidance, there's another step to go beyond that, which is thought exercises and challenges for ourselves to understand more deeply these particular areas. So I actually, in going beyond those messages, and I think this could zoom a little bit more. Sure. Going beyond those messages, I wanted to hear more about lack of cohesion of method. Show me that. And so it gave me these examples. So like I said, for the one I just showed, for this demo I showed, I prompted my way to this as opposed to writing it all out from scratch. What that means is, if you wanted to play with systems like this to understand this more, if you wanted to play with architecture, use prompt engineering to give you a leg up to get to the systems you want to play with and make changes to. So I went further. So this is me just talking to the thing. That it's you're the learner, you're in the driver's seat of learning, but it's done via conversations with the LLM. As it's almost like talking to your books. It's talking to your content. It's like when I would sit with my senior engineers when I was not yet a senior, and just talk about the areas. What are we trying to do here with this messaging platform with queues, and why is that useful for us? Why are we so service oriented? How does that relate to scale? Why are we using this technology versus that technology? And it's certainly helped. And so instead of waiting for another individual to answer your questions, you come up to your book and you talk to your book. What are the types of coupling? Because I just mentioned coupling. I didn't go into details on it. And that you can see here, hey, content common, data all the way to message coupling. We tested cohesion. And then of course, I'm gonna come back to that because I want to talk about connaissance simply because what is connaissance? And then you find the degree to which modules are dependent on each other and their behavior change in one causes behavior change in the other. It's critical that for our growth as architects and in software architecture, we have real deep conversations about this stuff, we reason about it, and then we use that reasoning to inform how we design systems going forward. Does that make sense? All right, I just mentioned some of these questions across there. And I just described our contacts manager. Let me see if I kept track of the conversation I had to produce it. Yep, I just wanted to show you how you can build a sample project. So I built this contact project. Most of the code came from talking to the custom GPT, but guess what? Even inside of that, I had to make changes, make tweaks, get this thing to conform to my goals. I remember one time Nicholas, you and I were talking and he was saying, some of your students sometimes are bringing ChatGPT solutions, but not even, the solutions don't make any sense. So it was funny because that's real. That's people simply coming and saying, let me prompt, get my answer and go my way. I saw Andrew Ng, he's a very well-known professor in AI. He's making the point that even things like GPT 3.5, which is now very far from the latest, can give you a lot of value if you take a different approach to how you use it. Instead of telling yourself, give me the one answer immediately, you should be saying to your systems to support you, let's work through and build towards a solution. It's what he calls, I believe he calls it agentic reasoning. And that's going to be a part of our industry going forward. Currently avoid it. So in my mind, we should find a way to do it with greater and greater efficacy. So because of how I build this particular agent, it triggers you, it asks you further questions to help you along the path in your goal. I definitely can share these threads with you so you can see it in detail. Right, guys, to wrap up, and before we wrap up, any questions, concerns, comments? Any of us, I asked a little while before, any of us could give us examples of how you use LLMs in your day-to-day? In the context of maybe development and architecture? Any of us ever gave an LLM an image of a system and said, okay, let's talk about the system and tell me benefits and challenges with it?
In a sense, yeah, I've used it as a research tool. Just ask something. I can't pull up an example off the top, but something I'm not sure about, and try to get some feedback on it. And of course, I'll try to ask for sources.
Sure.
It was really good HCI exercise where I wanted to understand some concept called interactive. Well, it called it interactive interaction. Sorry, let me see. Interaction capabilities, which is a kind of capitalization of the kind of features you could put in an app. And it was really good research tool in terms of finding sources and building up that.
Sure. That sounds perfect. Nicholas Smith?
Sure. How I use the LLMs, one aspect of it is using it to understand why the code works instead of just copy and pasting code, like understanding why it works.
I like that. That's pretty cool. All right, anyone else before we move on to patterns and styles?
Yeah, this might be a pretty basic example, but I did talk about folder structure.
Yes.
Yeah, and I actually find LLMs are good at giving you answers around stuff like that, like just how to structure a project. So in addition to code, which I guess most of us would use it for, sometimes we need some of the folder structure type work to be done. And of course, if you add some of the new agentic systems, it could actually set it up for you. So like Devin or Devika could actually go off and create those folders for you. So the grunt work is kind of taken away even before you start to to code.
Nice. Nice. I like that a lot. You mentioned Devin and Devika, and it's important. I just saw GitHub Copilot releasing an important update in that same vein. They moved away from simply code, like in module or in class updates. It seems as if it's grown beyond that, right into something like an IDE or IDE support in a different way. So I'm excited to play with that as well. All right, let's move forward and wrap things up, taking a look at architecture styles. I wrote this line and I'm concerned about it. I think it's true, but I hope it's less and less true. That really and truly maybe most software solutions are just big solutions and a big balls of mud. You know, people just start to write code, start to write classes, maybe try to make classes fit in some framework. Maybe in our space, it's what is expedient. But if we are interested in software architecture, we're interested in growing in a scalable way. We need to push back on those things and ask our teams to let's explore different ways to govern and build solutions that are more scalable and have better structure in it. And even if that is the case, let's find ways to enhance our structure, enhance our quality, which is what a course like this is about. So, fundamental styles in software architecture. It feels as if it's still broken down into these two, monoliths and distributed systems. Monolithic systems are single units that get deployed as a whole. I saw just recently someone was talking about monolithic. They use a term to kind of mean the system has parts, but it's still distributed as one. So if you make any change, you still have to change the whole system when you're updating it. Modular monoliths, I think is what it's called. We're not going to cover that today, but it's this idea that even though you have separate units, it's still treated as one logical system. I think there are benefits to it, but it's kind of beyond our conversation today. More classically, there's just distributed systems. Separate units that you use kind of remote access protocols to coordinate. In those styles, you have layered architectures and pipelines and microkernels on the monolithic side. I've been really thankful to have been able to play with that stuff and to build with it. When I say when I say play, you may hear it and be thinking, like just in little test environments. No, I mean play with the concept and then deliver it and deploy it for real. I'm very, very thankful for that, and it's allowed you to see the various ways you can express logical solutions. And of course, in the distributed side, the one that I'm least familiar with here is space-based, but we will talk about it a little bit just to get some clarity on it. Right, so on the monolith side, it's simple for the most part. You know what the biggest part of simplicity is? These things are true. It's simple to deploy and develop because you essentially would, for the most part, have a number of maybe threads internally. You'd have to push data across a network necessarily or push it across some communication pathway. You could have high performance. To the transaction part and the monitoring, gosh, nothing beats. And I was looking at I built this system where I had a number of functions, kind of web services and functions. Functions are serverless applications in Azure. So I had a couple of functions working with a VM triggering another web service. And I kind of wanted to enhance its telemetry. The way that sometimes providers out of the box support your telemetry needs, it almost assumes, I felt this, it assumes monolithic thinking. Like distributed transactions and distributed traces are hard to track. You have to really think about it to get it done right. And so when you don't have that to worry about on the monolithic side, it makes knowing what happened a little bit easier, makes reasoning about it a little bit easier. Sometimes it's difficult because even though you're inside of a monolith, if you leverage on threads a bit too much, you could find yourself really struggling to understand what your system is doing, what it's about. So there's a trade-off there, but for the most part, on the monolith side, easier to think about what your system is doing. when you see layered architectures, one of the things, there are a bunch of things on this slide. The biggest thing I want to focus on is Conway's law. I should have probably grabbed the definition from somewhere, but really Conway was saying the shape of your organization, the shape of the communication structures in the organization can determine the shape of your result, the software you create, which is crazy to me. But to be honest, if you work in a software team of more than a few people, then typically team is broken up into UI, UX, data, deploy DevOps or poorly named DevOps or Ops, and development. When development tends to represent the business layer and the business concerns. Those communication structures get mapped into how the software architecture looks unless you deliberately avoid it. And so building by default could cause you to look like a team. And what you do is, see this part down here where it says components are grouped by technical role. You tend to have systems that look like that versus being grouped by the needs of the domain. Once you lean into domain thinking, where there's a whole concept called domain-driven design. We're not going to explore it here, but there's a really good book to read on that and a number of good lectures you can listen to on that. Once you lean into building for the needs of the business domain, you find yourself beginning to avoid this because I think it's a problem. You shouldn't just map your team into your software. Instead, you should push for representing the domain you're building for. But layered architectures, which, as we said, could be a big feature in terms of monoliths. Typically, you've probably, anybody see this before? In terms of, you probably would have seen N-layer or 3-layer design, or this man working on the presentation layer, this man working on the persistence. Just hands if this is very familiar to you. Yeah, I mean, I see the hands going up, and it's real. This is honestly, when I did software architecture in school, way back as far back as school, this is what we were kind of taught. Software architecture was just layered. There was not much variety. I just thought when they build software, okay, who working on the presentation layer? You didn't realize there are many more ways to think about it, and certainly there are. So this is one. And so if you had to add, what you see here being closed versus open is referring to sometimes you require that there is no jumping between layers. You must go from presentation to business to persistence to database if the layers are closed. If they're open, sometimes a layer can pass through from one side to the other. And there are benefits to having that. But one of the things, even having a system like this does, is makes it very predictable in terms of how the building should take place. Even though it may cause you to build your systems in such a way that they're a little less flexible than they can be. And so when we talk about flexibility, we talk about ease of change and having the easy ability to change a system. And of course, there are anti-patterns. We are, as I said, we're not going to focus that strongly on design patterns only. We will talk about it, but we want to talk more about software architecture. But it's funny, the idea of anti-patterns is funny to me. You have design patterns and you have anti-patterns. And so an anti-pattern is really some aspect of software design that makes it into applications that, if it exists, could bring more problems and value. So an architecture simple anti-pattern is when you have essentially passing through layers and you're not really making use of the layer. And in which case you may need to take a step back and either reduce the number of layers or give that layer the appropriate work it should have. So here's some of the ways to address it: reduce the number of layers, refactoring to align more with your domain than the business that built it. And even if you have a small team, and this is something I think maybe in our neck of the woods in the Caribbean, if you develop in the Caribbean, you may see particular kind of standard behaviors. So you may have a small team, and I think small teams can allow you to be much more domain focused and role focused, because in a small team, people playing multiple roles, you can find that this is the standard way to think about it. And we need to get away from that, really. I mean, you don't need to if your software works and it delivers. But go back to slide 2. I think I mentioned slide 2 at the start of this section. Yeah, go back to slide 2. If it works and it supports the needs of the 5 or 10 users that you've been allowed to play with, fine. But if you're going to build for more users, you're going to build for thousands of customers, give yourself more freedom. Let's dive into one of those, another example from layered architectures into pipes and filters. It's sometimes you have to kind of search for opportunities to see how this thinking really makes sense. I remember having to do that for a messaging system without realizing I was using such an approach way before I even built my own. We were involved in configuring some web services in the past. And the way we configure the web services is you were allowed to add functionality, not by writing more code, but by specifying a new configuration element. So you could have said your web service started off, you have a core service functionality, which may have been perform some kind of algorithmic check, right? Maybe a health check or some system check. Just do something meaningful with data when it gets it. But before there, maybe you needed to perform a security check. You needed to have some new check related to data conversion. So as opposed to modifying the core code, you could have added in filters by configuration that would have modified the data on its way to that core section. And so I even as I said before, I actually built my own set of filters for processing data in that way. It was available to me as a part of a package in terms of building services. We'll come back to that in a little bit. It was very enterprise oriented, and that turned out to be very useful. So I just give you the example of a data processing system where you perform some transformation on each part of the data. That's what leads to the filters existing, and those connections are the pipes. So it looks something like this. You have your text. In this case, it's going to count the word frequency. Have your text, maybe normalize it by case or remove word endings, add or change word endings, things like that. Tokenize and then count. This is an example of that. And so one of the features of this is the data itself, sometimes in a system like this, the data can change along the way. Other times, you're actually extracting insights about the data for custom systems, maybe for telemetry purposes or for parallel systems to operate as well. When you use pipes and filters, it gives you a high degree of modularity. And of course, filters can be used across many different contexts, depending on the scale of your operation. It also gives you flexibility and scalability for your data. But there are some dangers to this. You can have too many filters, or you can have filters that operate slowly. So if you look at this, this is data moving in series. If one filter is taking too long to perform its function, it'll slow down everything else, unless either you parallelized it or you made your filters leaner and allowed it to operate more efficiently. I think this is a big point. As I said, my first use of pipes and filters was by configuration. So it literally wasn't hard coded. But you may, if you go back to, it was connaissance. I feel I'm pronouncing that wrong. Connaissance. However it's pronounced. You may build a system and a solution such where you can't change the sequence, and that may be a problem. Flow control is important as well. And so being able to mitigate those issues are important when you're approaching a pattern like this. And so the broader thing here is, as we talk about these patterns and these architectural styles, it's to be aware that the styles exist. So as you and your team build, you're able to, almost like a menu, pick from it and examine how it can impact your choices going forward. We're coming close to the end, everyone. Again, I draw from my agent, and this time when I was building this, I wanted this to give me diagrams. I still haven't done it the way I like. So this is just a mermaid diagram, but my next step here is add a copy it and then go to mermaid.live. It's kind of lame. It's kind of lame. Go to mermaid.live and then paste it in. I've been working on an alternative to that for a while now, but I ain't get to work just yet. So we stuck with this for the minute. But the point is, I could come to my agent. You know, we were talking about this in class today. Let me have some more conversations about it. Or some anti-patterns and some solutions that use it. And if you go down to these solutions, it was funny to see the example being the Unix shell, even though most of us piping for a long time in terms of Unix. And then of course the data processing applications and even streaming platforms. Now they mentioned Apache here as two examples. I've not used those. I've often used them on Azure for data processing purposes in the cloud. So it's a very popular approach, and so it's good to be aware of it. I'm going to hurry through these just in the interest of time. I actually thought I had been building and using this for a time, but this one is a little more difficult for me. I felt like I'd been using a system like this that we had built, but maybe there's some differences to what we were using. The idea of a plugin architecture is really important. And it's the idea that you have a core system performing operation, but you can add functionality, you can change functionality. So it sounds like pipes and filters, is just the way it expresses itself is different. Pipes and filters are, I'm processing data across some pipeline that maybe the pipeline can change, the filters can change, the data can change. And similarly, on the microkernel side, those things may be true, but there's a core set of functionality in your system that you can layer or add new features onto through plugins and plugin architecture. The example here, I'm going to run through this stuff for the minute to jump to the examples, which should be very familiar to us. If you use any modern IDE, think Visual Studio Code, you can add features onto VS Code without actually modifying the core function of it. That's a nice example of plugin architecture. Can you guys think of alternative plugin architectures as well?
I think if a game has modding options, they usually give you a kind of creative mods, and you just add a new code and it's already hooked into the life cycle in the game, so you'll just run it without changing the existing core. Your custom code is.
I had a really funny example. I was thinking about that's a nice example, Nicholas. I like it a lot, and it's very straightforward. A lot of us have used it in some way. Anytime we talk about game examples, that unfortunately I think about cheat codes in games. And I think about StarCraft many years ago when I used to play it, and that cheat code showed me the money that would make me get all the money in the game and never run out. I consequently never became good at the game, but I like the example a lot, Nicholas. I'm great now though. I'm great now at it. I'm like the best person. Anyway, that idea of pipes and filters, I just thought about a really useful way to think about doing it in the context of a mobile banking application. Not necessarily mobile, but a banking application. Often when I'm doing my own budget, I find you put the data across from the bank and then you have to shape it for, it's just a raw table dump. It'll be cool if that data could be, you could find a relationship between the bank's site and the ways you utilize money, almost like each way of using money is a plugin for the overall account. So if you make car purchases, that's its own plugin. If you make food purchases, and so it takes the core function of the banking application is to report on how money is used, but each plugin can give a different view on it, can do different summarizations, can explore so in the context of food purchases, alternative ways it could have been spent, more value could have gotten. It's just a really rich way to think about maybe an application that before would have just been a standard engagement, a standard delivery of value to a user. Right? I like that a lot. In fact, I think I'm going to explore that later on. I like the idea of the anti-patterns as well. This has been stuff we've seen in the past. The performance bottlenecks these things are extremely real, they happen, and so you need to mitigate both the idea that you've baked too many functions into the core kernel, or the performance, the communication is either doesn't perform well or it wasn't architected for scale. the way to think about all of this stuff, to be clear, is evolutionary. It's iterative. You make one change, you add, you explore how it could be better. So these styles and even the anti-patterns should help us understand how to explore and find new ways of delivering solutions. We're wrapping up by diving into a couple of distributed architectures. One of the goals of distributed architectures is to have high degrees of scalability and flexibility. It's really important that once you're trying to build systems that will treat with many thousands of processes or operations or users, that you find ways to scale it, and a great way is to break it apart from its monolith and give different aspects, different spaces to grow and run and be maintained accordingly. It also gives you the ability to have diverse technologies brought to bear for one solution. That part on iteration and deployment cycles is also true. You can be making changes more rapidly for different components of your system. But things can go wrong. I would have said it before. Tracing is problematic, but beyond that, once a network is involved, any assumption you're making about communication needs to be challenged. Things like latency and bandwidth for sure. Everything listed here I found to be true and needs concerns that need to be protected in some way, need to be treated with in some way. The big one for me, big one jumping out at me here is that ident topology not changing. Once you deploy it, then the security system, the approach to security may change between components. The needs from a regulatory or legal perspective may change around what architecture exists between the components in the network. And so being ready for change is very critical at the distributed level. And as I would have mentioned a couple of times already, logging is a pain if you don't think about it in advance, and oftentimes we don't. So you have to find yourself playing catch up with yourself and your system. Correlation IDs are a big challenge in this world, correlating what happened in one system with the next system and the third. I almost said it's fun because when you sit in it to figure it out, it could be like, oh, this is a real challenge, but it's also very frustrating because you find yourself, if you do it naively, you can introduce a lot of coupling to your systems and a lot of connaissance just because of logging. Because it means if you change behaviors in one place and you're depending on clarity for logging throughout your system, it really could cause you to have confusing results that you need to examine. Testing helps here a lot, but as it turns out, testing for logging is actually a critical thing that has jumped out at me over the last few years in my career. That you write tests to confirm your logs are working properly, as opposed to whatever the main features or the main function of the solution. I found that to be a really interesting one over the last few years. To run through, distributed quickly, what service-based architectures? Take your application and make it a bunch of services that deliver value to each other in ways that they grow independently. That allows for scalability and maintainability. Very often online platforms feature building using service-based architectures. This is service-based architectures, which is different to space-based architectures, which is the one I said was honestly the least familiar for me because I haven't done a lot of really big data applications in my career. It's probably something I want to do next and to play with, to be honest. But once you're involved in massive data operations, it's good to be able to locate the processing where the data is as opposed to moving the data to the process. So architectures that facilitate that are a really big deal and a good way to explore that. We'll come back to event-driven if time allows it, but this is, I honestly, is one of my favorite approaches to building software. Very asynchronous, related to responding to events happening across the application. It can allow for very scalable systems because you get to process at your rate of operation as opposed to the rate at which data is generated by a system. Often features systems that involved in Internet of Things, real-time analytics, and complex processing events. As it turns out, it's funny, if you build a distributed system, you may use multiple kinds of architecture to support the system. So for example, you may have an event-based architecture related to logging as a part of a wider system that may be space-based or maybe service-driven. So it's not that, oh, I'm only one or the other. You may have to mix and match to get the value you're going after. So I just mentioned service-based architecture. Service-oriented architecture comes from a very enterprise. When you enterprise here, large company, large corporations, huge systems, banks, insurance companies. That's where that term enterprise has a lot of play, and or even governments as well. In those places, service-oriented architecture often comes along with large-grained resources, large-grained systems to support them, including enterprise service bus, which we would not spend a lot of time talking about, but it's important to know it's a part of how those work. Microservices would be a lot of what many of us would have heard about over the last 2 years. Very popular. Build one system, but having multiple small applications as a part of delivering it. One of the big things I think microservices gives you, I mentioned it a little while ago, is the ability to mix and match your technologies. You can have a React front end with a serverless back end. Serverless back end may feature the use of Node on one point, Python on a third point, .NET on another place, all working together somewhat harmoniously. It's attractive, but though the diverse technologies, it sounds good, but in practice, enterprises like that their technology stack is under better control. So it might be one or few languages or frameworks that are separated across by roles and domains. I want to emphasize that you would have seen SOA, SPA, and microservices. They're slightly different, and the difference allows you to think about the applications differently. So for the service-based architecture, this is an approach. First of all, we're going to have a collection of services, and you could align those services to the business or the domain inside of, and of course, service independence remains true. Where you have service-oriented architecture, the complex service or orchestration may mean that you are using a tool to effect the creation of the services. So you may actually build or buy some or acquire some open source tool to realize the service-oriented solution, which is a collection of components to deliver the value. As you can see here, in terms of characteristics, there's often quite a significant use of middleware to achieve it. Can't talk about our system yet, but well, in my day-to-day job, we've been exploring how to deliver an enhanced approach to service orientation using middleware and some large-grained tools as well. So a little different from just broadly service-based. You can have many services, but they're not tied into the use of middleware. You can build a bunch of separate large-grain services. When you hear large-grain here, a service may have multiple functions, but they may be tied to a given domain. For example, orders or order service that allows for the creation, listing, and changing of orders, maybe one specific service, but it's not part of an enterprise service bus. It doesn't have service orchestration attached to it, that kind of a thing. So issues of service orientation can allow you to treat with a common approach to security, a common approach to logging, a common approach to authorization, registration of services into the system, a service discovery layer, service directories as well. Whereas microservices, small, independently deployable, fine grain is the key thing, and I mentioned technology diversity before. So what do these differences boil down to? As you can see here on the left, focusing here, scope and complexity on one side, SOA, as you could have probably realized, is more complex than, say, microservices. SOA, again, allows for organization-based and enterprise-based governance and integration. Reuse and independence is a big deal. You're moving more towards reuse and independence when you focus on services that don't necessarily tie into any any orchestration tool, orchestration system, or when you're building microservices. So to kind of close up on service orientation, here are some of the topologies or arrangements of artifacts that you might see. So you may have one common user interface that talks to separate components and talks to a common database. This used to be what I saw a lot of, and this is really basic. Instead, you might have separate UIs that plug into, or separate UIs that plug into a single user experience. Micro frontends are a big deal these days, and it's powered by a technology approach like this. Notice they're all talking to a common database, but you can vary the database as well. So to wrap things up, I wanted to end with a chat about event-driven architecture with my agent, emphasizing that once we end off today, it's not the end. Instead, we can be talking with our systems, talking with our LLMs about our systems to get examples, to ask, hey, I'm building this system. What are some of the approaches I can take? Now, I would still say, I would caution today that's not quite sufficient. In approaching an LLM about architecture, it's good to bring some data with you. I'm building a system to meet XYZ needs. I am trying to accomplish these goals. I think I would like to use an event-driven architecture and a microservice architecture. If you were to simply say that, it actually upgrades the level of feedback you get to allow you to think some more about your system. In this case, I simply said, describe event-driven architecture with movement diagrams. So you would have seen this before on the slides, and I focused on the artifacts or the components of event-driven architecture, and then give us this nice movement diagram. So you can see an event producer creates an event. It may go on something like a service bus, an event bus, which pushes the events across to consumers that then get exercised by given actions. So that's what event-driven architectures look like. And I'm going to stop there. I want to stop to get some questions from you if you have any, and kind of talk about what the rest of this course is going to look like. So any questions, concerns, comments?
Yeah, I have a question.
Go.
With the event-driven, if you could go back to the diagram.
Sure.
It would require action. Just trying to think of an example like this. So you might use some kind of queue. I guess that's what like the service buses.
Oh, good question.
Push on.
Yeah, sure. So how this service bus is implemented is up to the bus. An easy way to do it is via a single queue, or you can, so I've used Azure Service Bus for a while, and it may have queues underlying, but it may expose to me a web service endpoint that separates the messages by topics, and each consumer subscribes to a topic. So it's a publisher subscriber relationship between the bus and the consumers that pulls or receives notifications from those topics. It may be, there's another tool called the event grid, where consumers subscribe to events and producers publish to the events. So the bus is not, I don't limit it to what you may have heard as a service bus or some enterprise bus or even a bus itself. It could just be a regular old queue, a RabbitMQ queue, for example, with distinct topics on it that get consumed accordingly.
Right. And so these consumers, they could just be other servers that just receive and post requests. That these notifications come in the form of post request.
Yes, so that's a good question again, in that the form of communication here can be diverse. There's an actual queuing protocol for notifications. In fact, there's something called, it's called cloud events. Yeah, there's a specification for describing events in a common way. So cloud events exist to provide a kind of an industry standard across how events could get communicated. The interesting thing there is the protocol for communication can vary. There's a queuing protocol. Its name escapes me for the minute. You can't use HTTP. You can use any other kind of protocol once the consumer is oriented to receive it.
Okay, all right, thanks.
Yeah. So as we wrap up, any questions, any final questions at all? So today we spent time so we know who we are. Everybody here is the target audience. Welcome, problem join, guys. Today we spent time focused on foundations. We spoke about architectural thinking and the roles of architects, and then spent some time looking at patterns and styles. Key book for us today was the book Fundamentals of Software Architecture. We do want to lean into design patterns next week a little bit more, and then talk about metrics. I think metrics are pretty important to go along with. If you propose a particular design, you propose a particular approach, how do you know it's working? How do you know it makes sense? And I think we will heavily spend time on metrics. We will touch, having done the content in some detail, we will touch on lean software and DevOps from Accelerate, but not fully. We'll start talking about it on week 2, and we'll continue in week 3, spending some more time looking at things like scalability and reliability and security in particular, along with more messaging patterns. Week 4, we want to spend time talking about careers, some of the roles we've been seeing emerging in software engineering, ways to grow from engineer to tech lead and beyond that, the business of software as well. And someone asked about the capstone project. Next week, we'll talk about what that project is and how we'll evaluate it at the very end. So that's it really in terms of delivering this course. I want to thank all of you for joining today. Thank you for the questions. I know we have a bit fewer than when we started. 3 hours of software architecture could be a lot. So thank you for staying to all this way. I look forward to all of you joining again next week. The university will reach out to you, or you can reach the university about how we deal with things like payment. But I was happy for this. This was a lot, to me, fun, though tiring, as you could imagine. And I am looking forward to how we do more of this. Not just across this course, but across the region, and make this a normal part of our flow. Developers need to talk and share and exchange ideas, and I think this is one of the great ways of getting it done. Nicholas, thanks for your support again, and let's chat again sometime soon about how we build this thing out. Cheers, everyone.
Awesome. Good day, everyone.
All right, thanks. Take care, everybody.